So I've given you a little bit of time to try to solve this. And the whole purpose of this proof is to prove that two objects, it doesn't matter what those objects are, here it's a ray and a line, but it could be a ray and a segment, or two segments, or two lines, or a line and a plane, whatever. We're trying to prove that two objects are perpendicular. Given that the angles that are formed by the intersection of these two objects, you're given that those two angles are congruent. Okay? Now, like I said, I've given you a little bit of time to work on it. And if I were you, below that, below your attempt, I would start anew and say, okay, this is what I was thinking, this is my own thought process, or maybe you and a friend when I let you work together. And then below that, write, okay, this is the answer. So you can compare and see, okay, well, I shouldn't be thinking that way, but maybe it's good to be able to compare. And also, you need to see your thought process. It shouldn't be upsetting or belittling that you have to start anew. I mean, that's problem solving. Engineers, every single day, they are given a problem and they need to try to figure it out. Sometimes they have to scrap everything that they started and start fresh. So it's not a bad thing. This is just the process of solving a problem, starting fresh. Okay, so I'm going to move this kind of high up here. And what's probably going to have to happen is I'm going to start my statements and reasons here, and I'm going to have to continue and write some down here. All right, here we go. So, some of you that got stuck, once you wrote the given, because you always begin with the given, pretty much the only thing you can say after that, after the given, is, well, the measures are equal. If you have two congruent angles, that means that their measurements are going to be equal. So we've used up the given statement. There's nothing really else we can do with this, the fact that these two angles are congruent. Well, we can say that the measures are equal. When that happens, we have to look towards our diagram and ask ourselves, what is the diagram telling us about this situation, about these two angles, about these two objects? What is it telling us? So we can see that the diagram's marked that those angles are congruent. We already know that. What new information can we pull from the diagram that describes or gives us more information about these two angles? Mm-hmm. Yeah.
Angle RTA and angle QTA are linear.
Okay, they're a linear pair, which means what? How's that going to help us? They're supplementary. Okay, so that's the information that we pull from our diagram, is that those two angles that we were given are congruent. We know that they're also supplementary because we can see in the diagram that they're a linear pair. And by the definition of a linear pair, we know that they are supplementary and adjacent. I'm not going to waste our time writing adjacent though. The definition of linear pair is two adjacent supplementary angles. So we got this third statement just from looking at the diagram. We can see that those two angles are supplementary because we can know that they're a linear pair. Well, if two angles are supplementary, what else can I say about them? Yeah, turn that statement, number 3, into an equation that's transferring you from talking about objects and transfer into talking about their measurements and writing an equation that represents this. So saying that the measure of angle RTA plus the measure of angle QTA is going to equal 180 degrees. And we know that that's justified by the definition of supplementary. So these are my statements, those are my reasons over there. Is everyone okay from here? Now, and this is, I'm just speaking hypotheticals, okay? Because I don't know where you got confused. I'm not sure where you got stuck. I'm just trying to throw out different scenarios, just in case that if you ever get caught in one of these scenarios, you'll have some sort of strategy, some sort of plan of action. So maybe you got all the way down to step 4, and then you got confused, and then you had no idea what to do, okay? Well, earlier I said if you got stuck at step 2 and you're just like, well, I don't know what else to do, well then you need to look at your diagram and figure out what is the diagram telling us. And so that's how you got these 2 steps. If you get stuck again, you need to start, maybe, this is what you need to do, is start working backwards. You know that we're trying to prove that these 2 objects are perpendicular. So think, how am I going to do that? What do I need to show? Well, if I'm going to prove that 2 things are perpendicular, I've got to prove that by the definition of perpendicular. And what does the definition of perpendicular say?
Two lines intersect to form a 90-degree angle.
Does it say 90-degree angle?
Right angle.
Right angle, okay? If perpendicular means 2 objects intersect to form right angles. So we know that if we're trying to prove that these are perpendicular, I have to somehow show that one of those angles is a right angle. Okay, well, what's the definition of right angle? Or how am I going to show that that's a right angle? I have to show that its measure is 90 degrees. So now we're making the transition into its measurements. So I have to somehow show that one of those angles is 90 degrees, its measurement is. Okay, well, I know that their measurements need to add up to be 180 degrees, so, and I also know that their measurements are the same. And so just by working backwards, I can see, oh, okay, I need to somehow take this equation and show that just one of them is equal to 90. Well, we can do that because these have to be equal, the same value. So the next step from here is taking this equation and replacing one of the angle measurements with what it is equal to. Because this right now is one equation with 2 unknowns, 2 variables. Because I don't know what the measure of angle RTA is, and I don't know what the measure of angle QTA is right now. So this is kind of like x plus y equals 180 degrees. Well, we have no hope, no chance in solving one equation with 2 unknowns. So we need to take this one equation and put it in terms of one variable. So like x plus x equals 180, or y plus y equals 180. We can manage that, we can solve that. Well, luckily, these variables, they equal one another. So you need to replace one of those variables with what it is equal to. I think I chose to keep, angle RTA. So the measurement of our angle RTA plus the measurement of angle RTA. All I've done is I replaced the measure of angle QTA with what it is equal. And so that is justified by substitution. If you're just plugging values in, you are substituting. So this reads, the measure of angle RTA plus the measure of angle RTA equals 180. Now what? Combine like terms. I would also accept simplify, but I like combine like terms. I've got, like this now reads x plus x, because this is just a big ugly variable. So I have one of the measures of angle RTA, and I have a second measure of angle RTA. So I can combine like terms, and I can get 2 of these. Combine like terms. I've seen some people say that this is like the distributive property, but combine like terms is totally cool with me. Or simplifying. I'm totally cool with that. Okay. Now what? I've got 2 of these measures of angle RTA equals 180. What am I going to do next? Yeah, I'm going to divide by what? what allows you to divide by the same value on both sides of the equation?
Division property of equality.
Division property of equality. So now, when I do that, I get the measure of angle RTA equals 90, and that is justified by the division property of equality. I've just divided by 2 on both sides of the equation. Okay, what am I going to say after that? What was our whole point of doing all this stuff? Right. The whole purpose in showing that the measurement of one angle was 90 was because we needed to get to the fact that one of those angles is a right angle. That was the whole point of doing all this stuff with its measurements. We were trying to get down to show that it's a 90-degree angle because we needed to show that it's a right angle. And I know, and we've talked about this many times in this class, but it seems a little weird to say that this angle is a right angle because of a right angle. I know that seems weird, but that's it. The way that you prove an ordinary object, any random angle, is a specific angle or a special angle, you have to prove that by the definition of whatever angle. So if I needed to show that this angle was a straight angle, well, you would need to show that by the definition of a straight angle. That's the way you prove things. And we know the definition of a right angle says that if an angle's measure is 90 degrees, then it is a right angle. That's what that says. From there, step 9, what do we got? Yeah, we're done. We've shown that it's a right angle, so you have your proof statement. These two objects are perpendicular, and again, it's by the definition of perpendicular, because the definition says that right angles are being formed. So we have shown that one of those is a right angle. So number 9 is just your proof statement. You're done. The reason is by the definition of perpendicular. You're going to use this. We did this last class. We did this last class when we proved that the diagonals of kites are perpendicular. We did this last class. Okay. Any questions about this proof? Proving that two objects are perpendicular? Yes, ma'am.
Do you always have to put the given first? Like, couldn't it have worked if you plugged it in, if you made it step 3?
You're saying you switched 1 and 2 with 3 and 4?
Yeah.
I would accept that.
Okay.
Okay. But traditionally, you do start with your given.
Okay.
But I wouldn't mark off points. Good question, good question. Alright, that's the warm-up. Cool. So let's